you can see from this slide, this is going to be about http4k and server as a function. And it's going to be mostly live coding, so there will be not that many slides. So http4k, it's a library for KotLand, written in KotLand, which provides a nice and small abstraction on top of HTTP, emphasizing the essence of what HTTP is doing. And it has emphasis on simple design and testability. And we will see it quite soon. So to illustrate how http4k works, I will write a small program which will simulate a board from tic-tac-toe game, also known as Nuts and Crosses. So it won't be the game itself, it will be more like a board from the game. And the design of it will have like two components, front end and back end. So front end will get requests from the browser, forward them to back end, and back end will send back some JSON, which will be rendered by the front end. So kind of somewhat typical design, I guess, for web applications, front end and back end. And for the demo, I'll use IntelliJ and KotLand. So without further delays, I'll just switch to IDE. So this is IntelliJ IDE in presentation mode, and here is Hello World. If I run Hello World, as you can expect, it prints Hello World, and that proves that it works. So moving on to http4k, the main abstraction in http4k is an HTTP handler, which is a function that takes a request and returns a response. So in this case, let's write hello world first. So I'll create what I'm doing. I'm defining an HTTP handler which takes requests. We're not using it. And then we return in response with status OK and body saying hello world. If I run this program, it will not terminate because it's now running in the background. There's an actual, in the first place, this is not actually doing anything. So I was wrong. Because this is HTTP handler, it's just an alias for a function. So if I go to the source code, we can see this is a type alias from request to response. So there is not much to it, not much framework. And because this is just a Lambda, it won't actually run. So the program terminated. We need to ask http4k to plug it into an actual server. And in this case, for no particular reason, I'll use Apache server, and let's run it maybe on port 8080. And now it will run. And we will see that it will not terminate and will wait for requests in the background. Now I can go to console and, for example, do this curl command to localhost, and we get back hello world. We can also do curl with more arguments, so we can see that we are sending actual requests from curl, so that's outgoing traffic, and that we are getting back header from Apache. So that's how you can do hello world in http4k, but then it would also be nice to write a client in KotLand itself. So I can define an HTTP client, which is also going to be an HTTP handler. And for HTTP client, I'll use HTTP integration with a KHTTP library. For HTTP client, all we need to do is to pass a GET request into HTTP client, like an object with object request with the request of what we had, and it will be localhost at 8080, pretty much what we had on the command line. So this is going to be response, which we can print. So if I run this now, we should see in the console in IntelliJ also the response that we got back from our own server. So we get back pretty much what we've seen on the command line. So it says hello world. The important thing here is that both client and server, they are HTTP handlers. So if you remember one thing from this talk, remember this, that both client and server, they are exactly the same. So if I specify type here for the request, you can see this is the same request as the request we send into the client. And if I specify type for the response, it's the same response that we are sending back from the server. So server and client are identical, so they're interchangeable, and this kind of designs, it's quite simple, but it unlocks lots of interesting things. What we have right now is a server which always just says hello world. So even if I do foo, it will not really fail because we don't have any routing. So let's add a bit of routing, which we can do with routes function, which is part of http4k core module. And it has a small DSL, so I'll write it like this. Let's say hello bind, then get to, and then I'm pasting exactly the same lambda that we had before. So If we run this now, we would expect 404 because we are binding our code to /hello, not to foo. We also can maybe pass a name and customize our hello to be more personal. So let's say we have name, and then we can extract the passed-in query from the request using this query function. And so now I would expect to see hello Bob as a response from the server. So we get back hello Bob. That looks good. So roots itself, it's a function. It's a roots, as you can see from the type signature, it's also implements HTTP handler, and it takes HTTP handlers. And we could add more roots here. So it's kind of a fractal thing, and it's all composable and easier to combine. So there is a question though: what will happen if, let's say, we forget to specify name? And the answer right now is that the type of the query we get back is a nullable string. So we will get hello null, which is maybe not ideal. So let's add a minimal an error handling and say name is required. If I run this now, we'll see what happens. But right now we're going to throw an exception because there won't be a name. And what we're doing, we're not really handling any exceptions here. So if we look at the source code, though, if we look at the response, we are getting 500 response, even though we are not doing it explicitly in the code. So what happens, as you can see from the stack trace, it's http4k default filters. They are doing it for us. And it would be nice to handle our own errors ourselves. So to do this the most idiomatic way, of course, we could just wrap this into try-catch block, these 2 lines. But a bit more idiomatic way is to use the second important concept in HTTP4k, which is a filter. So filter, again, it's just a function which takes a handler and returns a handler. This is identity function and the simplest filter you can possibly write. So we can plug it now into our handler like this. So we say filter. This filter is not very useful. So let's add maybe a wrapper handler here to make it a bit more useful. Wrapper handler is going to be HTTP handler, which takes a request, and then it calls the original handler with the request, and then we can return wrapper handler. This is still obviously not doing anything, but now we can surround this with try-catch, and when we get the exception, we can return a response, say with status IMT-port. So to be clear, when we call this handler in line 13, we are actually calling these 2 lines 23 and 24. So that's what filter is doing. Also should probably call it catch-all, to be fair. And when I run it again now, we are getting back response I'm a teapot because our filter is catching the error which we throw on line 23. Well, there are some built-in filters which come with HTTP4k, and they can be useful. One of them for development purposes, print request and response. And import this. And what's interesting is that you can chain filters using this function called then. And so if I extract this into variable, I'll call it filters because we're actually combining 2 filters. The interesting thing, though, is that the type of this filters is still a singular filter because it's not a list of filters. And this is because filters are combined using functional composition. So that's kind of just functional programming. So let's plug these filters in. And also catch-all, there are some built-in filters. So we can go and say server filters, and there is catch-all filter, which probably is a bit better way of writing the same thing. So we will see stack trace again now, but we also see these outputs from the debugging filter. So that was our get request, and that was our response. And then there will be response once again, which we are printing on the console. So that's kind of advanced hello world to HTTP4k. But there are 2 main concepts, which is HTTP handler. We can go look at the source code. It's like a function which takes a mutable request, returns a mutable response, and filter, which is a function which takes handler and returns a handler. So it's like a wrapper around handler. These are the only 2 things you need to know, pretty much. And there is no magic. It's just functions calling functions. You don't need anything special. So before moving on to the actual tic-tac-toe board, let's do a bit of refactoring. So I'll inline this filter, import this. I'll inline filters variable as well. We don't need the client anymore, and we can extract all of this into a function called new backend. And can inline HTTP handler. So the whole main function is a one-liner now. And this new backend will be basically our server as a function. That's literally what it means. That's our whole server. So to illustrate testability, I'll just write, the next thing I'm going to do, I'll just write some tests, because that's what we kind of do in TDD. And I'll create a class called backend tests. And I'll create a test called state of an empty game. Because our server is literally a function, we don't need any dependency injection or anything. We just create a variable and call it backend. I'll make it private. And to use the server to start calling it, again, we don't need to do anything special. We just call a function on the backend. We could, of course, start the actual server and do it via actual network, but because it's just a function, we can just go ahead with this. So what we want is to call an endpoint called game, and we expect a status. I'll create extension function on the response, which will check the status response. And we expect it to be status OK, and then we can return the response. This will give us back a response variable. And we can assert that we can extract the body from the response body as a string, and we expect some JSON back. I'm not sure what it's going to be, so I'm just putting it as some JSON. And let's see how this fails. So it fails on this line, saying that it expected 200 but was 404. That makes sense because we are not even handling game in our routes, so let's do that. Then here, ... just put ... and we don't really use the request. Now I would expect the test to fail on the next line, on the assertion on the JSON. So fail says expected JSON was ... which makes sense. So what we want here, we want some kind of game object here. Let's define game, which I will define in a kind of functional way. So it will be a game with list of moves, where move is also going to be a data class, which will have X and Y variables. And it will have a player who made the move in that cell. So X and Y, these are coordinates of cells on the grid. It will be between 0 and 2. This will be 3 by 3. And for the player, it will be enum of X and O. That's the idea. By default, we can have an empty list of moves. We have game, and we want something like game. Well, for now, I'll put game to string, but we want to convert this to JSON. So let's see how that works. We would expect some failure on here. Should look not ... Yeah, so that's representation of game to string. Of course, we could do something like to JSON here, but then nothing stops us from doing it. That's a thing we can do. But there is a bit more idiomatic way of using http4k, which is using lenters. So once again, that's an example of that's an optional thing, but that's an example of when library is more beneficial because it doesn't force you to make any particular decision. So you don't really have to do that. So length is a concept from functional programming, which we'll explain in a second, but it looks something like that. And I'm pasting from a specific place import for autobody because that's like still a problem with KotLand support. So autobody is just a function on an object, but KotLand plugin doesn't understand that it's there. So it compiles fine, but the plugin doesn't show me the import. And so with lengths, what we can do is basically lengths. There are different ways to think about it, but the simple way is to think that it's an object which encapsulates getter and setter. So in this case, we want to use a setter, which is called inject. So we're injecting game, and we are injecting into response with status OK. And that's all we're doing. So Relens will know how to convert game into JSON And in this case, it's coming from Moshi library, so it will use Moshi to serialize game to JSON, and it will know how to set it on the response object and will return a new immutable object. So this time we're getting failure saying that's the output. And this looks fine to me, so I'll just paste it back into the code. So that's the simplest thing to make this test pass. So let's move on to the next test, in which I'll try and make more moves. So let's call it maybe players take turns on each move. It will be like players making moves on the board. So for this, we'll have a post to the game, and it will take two parameters, x and y. And we expect this to be okay, and let's have a couple more moves, say 0, 2, 1, and 1, 1. And at the end, we'll do pretty much the same thing. We're going to query the state of the game, and then we expect some JSON again. Run this and see how that fails. So it fails on line 15 because it says method is not allowed. What happens is that we have binding for get, but we don't have a binding for post. So I'll copy it and create a binding for post. Well, so what we want for post is, well, let's just return a K for now and see, move on to the next failure, doing it in a proper test-driven way. And now we see that we expected some JSON, but we got JSON with empty moves. And this makes sense because we just hard coding this game here. So at this point, we need to create some mutable state. So I'll convert this to block body, the whole function, and I'll move game out. We want we want something like modifying the game inside here. So something along these lines. We want to make move and have x and y taken from the browser. So when we click on a cell in the browser. So we don't have x and y yet, so let's define those. Here, what we can do, we can use query like we did with the name in hello world and convert it, for example, to int. Say to int or null. That's one way of doing it. Question. But now the idiomatic way would be to use lenses again. So here I'll use xlens, which will be a lens on the query. Just have type int, and it will be required with name x. I'll also define one for y. In this case, we want a get functionality of lens, which is called extract. And we're extracting from the request, and we're getting back x. Here, x will have type of int already, so it's not nullable, and http4k is doing parsing for us. It's convenient. And if the lens fails, it will throw an exception, which, like in the real world, we would handle with some filter. Now that we have x and y, we can maybe make the game a variable, and we can create make move function. We'll create it as a function on the game itself. At this point, though, if we look back at tests, we kind of testing our domain through the backend test. So that's not ideal. In the real world, I would say maybe this is the point where we stay and stop and create tests, for example, for the game itself, and we write tests here instead of doing it from the backend. But let's imagine we kind of done it properly. So I'll just type some code here. The simplest was what we want to return a new instance of the game, which will have moves copied plus a new move. So for the move, we already know x and y because that's where player clicked on the screen. And then all we want is to determine next player, which is not too hard to do because we can check the moves, and if the moves last or null, so we look at the last move, and we can take a player from the move, and if this is not player X, then it can be null or player O. So in this case, the next player is X, otherwise it's O. So let's try that and see how that works. So this time we see the failure with this big JSON, so I can paste it back. Nothing stops me from doing that. And maybe then if I did this convert to literal, so it's a bit easier to read. This kind of makes sense to me, and I'm pretty sure that will pass, but it's also kind of becomes quite long. So at this point, just to illustrate it, we can reuse game length once again. And we can, for example, just use it on the response, and game length will give us a game object back. So we can assert more like on domain objects instead. So what we expect back is couple moves. So this was player X first. And there will be a couple more moves, player O, 2-1 and 1-1. So this should still work. So that's an example that lenses that can be useful also in tests. Although in some ways it's kind of nice to see the JSON that is produced and have some examples in tests. So this test passes, and this is like the minimal implementation, but in reality, I'll write a bit more code, which we can pretend that is driven. So we also want here to have a winner, which is going to be a player with question mark. So to do that, we can say find winner function. We also want to make sure if there is a winner in the game, so winner is not null, then on the move, we just return the current game. And to define the winner, I'll just define a function here, which is going to go through all players. We can go through all the num values, and we want to find the player which made all the moves in the row. So the idea is to generate all possible moves. For example, we'll map from 0 to 2 and generate all the moves on the first row. So it's X is going to be fixed and Y is going to move, and this is going to be the current player. So these are all the moves in the top row, and we want to check that moves contain all, something like that. Or we can have 2 more rows. So I'm just copy pasting the whole thing. And then we want the same thing, but with Y. So we can do like swap these coordinates. And we can have like one diagonal and the opposite diagonal. So that's a simple way of defining the winner. I'll run this again, but let's hope it works. And we'll see when we actually try it out a bit later. So the test still passes, and at this point, maybe it's the time to do a bit of refactoring. So one thing I would do would maybe extract this game as a parameter and call it initial game. So this way, when we construct the backend in our main function or in the tests, we can pass in game in any state. So for example, if we want to test how the winner functionality works, we can pass in a game and see what is the response from the backend. That's one thing I would refactor. The other thing, which maybe is not that obvious, is that this is not thread safe, because http4k is just like a thin layer on top of several HTTP servers. It's not really doing any magic, and all these callbacks that we have, they just called on whatever thread, in this case, Apache will use. So this is not thread safe, and I don't necessarily like it. What I'm going to do, I'm not suggesting this is a great thing, but just as a reminder for ourselves that we need to think about thread safety. I'll use atomic reference here. So we want our game to be updated. So I can say something, update and get. This will do. This is more like for us to be mindful what's going on. So I'll run the test again. And this will be pretty much it for the backend. It will be a very simple backend. So these are all the tests for the backend. You can see the pass. So moving on to the front end, we kind of don't necessarily have to do it in http4k, but I'm doing it just because you can, and just to show that it is possible. So we could have written it in Node.js or whatever. So let's just sketch maybe the function which will create backend and plug it into main function. So if we create a front end, what we need is we want front end to be talking to the backend, so that it will take backend as an argument. And then we want to return some roots. So I'll copy roots into here. And say it returns something, and the body will be just some HTML in game. To plug this into main function, once again, we can just create it like this. And because we're running everything in the same process here, we could have passed just a reference to the backend. But let's pretend these are in two different processes, so we cannot really access this one. So we can create a backend client here. And for backend client, once again, I'll use integration with HTTP. And we'll pass it like this, and then we'll have, we need to, again, start the front end as an actual server. So I'll run the front end on 8080 and I'll switch backend to 1234. The problem here now will be that whenever we use backend in our front end, we kind of need to know the address of the backend when we make requests. Might be not very convenient. So to do that, we can use a filter which will always set our URL to a certain URI. So it will look something like that. Yes. There will be URI of HTTP 1234. So that's the address of our backend. So every time we use this backend client, it will use this base URI, basically. So that's it for the front end. So let's write a quick test for it. Write front-end test. And it will be a similar test, which it will be a state of an empty game. And because front-end, again, is just a function, we don't need any dependency injection frameworks things. We can just create a couple functions, and that will be it. Front-end, private, and to call the front-end, once again, we can just do get request to / and then we expect it to be okay. We get back a response. And this time I'll do something slightly different. I'll use an extension for JUnit, which will use approval tests. So this is called approval test. And this is part of http4k testing module. So http4k has several modules, and our module is minimal, and there are also a few other modules. So this approval test is part of another module of http4k. So what it means is that we can get an approver object in the test, and we can say assert approved response. If I run this now, I expect that it will fail. And it will fail because there is no approved content. So what this approval test is doing, it's calling our, we're making the call to the front end, and then it gets back a response, and it looks for a file called .approved. In this case, we didn't have any file, so it just created one for us. If we look at the content of the file, we'll see that's the output that we produced, and it's just some HTML. If we want the test to pass, we can just rename this function to .approved. If I run the test again, it will pass this time. That's the idea of approval tests. They're also known as snapshot test or like golden master test, but approval is the best name for it because it's not about like golden master and it's not about snapshots. It's about humans checking it and approving the content. So we don't want just some HTML here. We actually want to render something, and http4k has integration with a few rendering engines, so I'll use here handlebars. So we can say I have a renderer, and it's going to be handlebars. And preload, and I'll use src test because this is where we are just putting everything into test for simplicity. So to render things, we want a game view objects, which will represent kind of view object of the game. I'll define it right here again. So it will be game view, and it needs to extend the tagging interface view model. This should work. Then the other thing we need to do is to create a game view HBS file, where HBS stands for handlebars. And here I'll just paste a bit of code and I'll write hello world. Not sure where people are watching from, but I'll put Ukrainian flag because it's supposed to be in the Ukraine. If we run this now, if we run tests now, we should get a failure once again because we changed the output of our front end. So it will now be returning some HTML. If we take a look, so this should be this line. And now we have two files. One is approved, that's what we approved last time, and the other is actual. I can diff them. And I can see that on the left, we have the current output. On the right, we have the old output. So now I can maybe delete approved and rename this file to approved again. This is kind of all fine, but it's also, approval tests are fine, but it's also always kind of good to check yourself if things are working. So let's maybe run it, the actual program, because I never did it. And let's see in the browser how it works. So I go into localhost and I refresh it. So it actually rendered something. That's good. So moving on with our implementation, we don't want to just return an empty game view. We want to request game from the backend. So we can just do a GET request to the backend. As you can see, this is quite easy. What we get in, we want to get it from the game. What we get in back is a response with JSON. And luckily, we still have game lengths here. So we can just say game length extract. That's the getter functionality of the length. And we get back game. So that's quite straightforward. And of course, we're not doing error handling. It's just for simplicity, skipping all that. And what we want really is to convert game into game view. So because it's a little bit boring converting all this, I'll cheat a bit and I'll just paste some code which already does these things for us. So our game view will be a grid of rows 2 by 2, like 2 nested lists, and it will have a winner, and each cell will be done as a cell view. It will have X, Y, and player. And the whole conversion to the game view from game, it's like 2 nested loop X to Y, and we return cell views for each of these loops. And we find player matching it on coordinate of the current move if there is one. And we also want something which matches this in the HTML. So I'll cheat once again, and I'll paste a bit of code here. So this is easier to look next to. This is easier to understand next to each other, these bits of code. So inside the handlebars template, our context will be game view object. So here on line 3, we iterate over rows, which are these rows on the left. Then inside each, we check in player, and that's the player inside the cell view. And if there is a player, we show it. Otherwise, we'll have a link on which you can click. And at the end, outside of the loop, we check in for the winner, which is the winner on the cell view. So that's the idea. So this should already work. So let me just run the test and see that we get yet another approval failure in this line. Ran main function. So we get another failure, and we have 2 files. So it looks fine to me because we get some HTML. So I'll just go ahead and approve this once again. There are tools to do this faster, and you can automate this yourself. A small script, for example. This will work now, and I can also try it in the browser. We can see now the grid, but if I click, it takes us to nowhere. Well, not to nowhere. We don't have this endpoint for /move, and this will be the last endpoint that we make. So I'll do test first once again. I'll copy some of the backend tests because they're going to be kind of similar. Instead of this, we're going to have front end. We'll have a get just because it's easier to do. And for no particular reason, I'll do it like this, encoded as a path. And at the end, we'll do just one more approval session again. And this. And I expect this to fail on line 18 because we don't have endpoint for /move. So this is failing, so let's create this endpoint on the front end. This will be move, and then we need to extract nx and y from the path. And in http4k, we can do it using this curly braces syntax. So what it means is, let's say we return a k, and what it means is that now on the request, we can call path function and specify x. This will give us back x, which is going to be just a string, but we don't really need much more because all we want here is to do a post request to the backend and pass in x and y to it. X equals $y. Once again, let's just ignore the response. And after this request, we don't want just a k, we want to render the body again. And we could have just called this as a function, for example, extract this into function. But there is a bit more HTML idiomatic ways to use the other response, and we can specify header on the response, which will have location and slash. So that's basically forwarding browser to this location. Let's run this. It should hopefully work. And was like 303, see other. The reason is that all we're doing here, we just call in functions, and they don't do automatic forwarding. So to do that, what we can do, we can have client filters. We can add the filter which will do forwarding for us, and we can define this filter called follow redirect, and we can wrap it around our client and test. So now we should get all the redirects working. So it failed now, it took a while. It failed in a different line. And it says like there is no approval test. So let's take a look at the actual. We can see there were some moves, but at this point it's kind of hard to see it in HTML. So I would prefer to maybe run it and see if it looks fine ourselves. And so let's run the main function. So I'll refresh the page once again. Now if I make a move, you can see X appears. If I do another move, O appears, and let's maybe test it by seeing, yeah, we get X as a winner. If I click on these links, nothing happens, but this kind of works. And you can see this is a prototype because to just start a new game, I need to restart the whole backend, or the end front end. Let's try and make O win this time. Maybe X. So yeah, that works too. And the hardest thing is to get a draw. So let me refresh this. It can be tricky to figure out how to do a draw sometimes. No, X wins. Oh well. Just as a quick overview of the code, what we had is we have a main function, then we had front end with 2 endpoints just to get the whole state of the game and to make a move. Then we had some classes to represent the front end, how it renders things. We had some lenses. We defined backend with 2 endpoints to get the state of the game and to modify. And we had some domain objects, which, like all of these sections, they should ideally be in separate files, of course. And just for simplicity, I kept everything in one place. And in terms of tests, we did some backend tests, front-end tests, and you can see there is a bit of similarity in all the names. And I was doing it kind of on purpose just to show that you could potentially extract some common testing logic so some common testing logic, so you can test like the same thing at the domain level, at the backend level, or the front end level. And all the testing we've done it was in memory because for http4k we were using all this functions. They're just HTTP handlers. And we were doing it memory, so it would be really fast because it's literally just calling a function. But nothing stops us from really using, like defining backend as a client and then calling a real server over HTTP, it will be a relatively simple change. So that's the power of having simple abstraction on top of HTTP. So that's it for the demo. So what we've seen is kind of just an introduction to HTTP4k. There are more things. So there are more integrations with HTTP clients and servers. HTTP4k doesn't reinvent the wheel. It integrates with different libraries, HTTP libraries and HTTP servers and clients. So it's not really running its own server in the background. And there are integrations with other JSON XML libraries, other template engines, and serverless platforms, the thing I didn't even mention. So we've seen some approval tests, which is might look like a simple thing, but it's actually a big topic on its own. Because HTTP4k has this uniform HTTP interface, it makes it easier for contract tests. You can also do chaos testing using filters, for example, and it also makes it easier to record and replay traffic. And if you remember one thing, so that client and server in HTTP4k is exactly the same type signature. So it's an HTTP handler, which takes an immutable request, returns a mutable response, and there is a filter around it. So that's all you need to know. And in terms of the next things you can try, you can find everything I showed, all the slides, all the code. It's all on GitHub. You can take a look once again at this. There is also a project called HTTP4k by example under HTTP4k repository on GitHub. So that's the authors of HTTP4k. They have like an exemplar project. You can take a look at this. And obviously HTTP4k itself is an open source Apache license. You can find it on GitHub easily. You can see that it was developed by David Denton and Ivan Sanchez. I'm just looking at the contribution history. And you can see talks by these two guys, Dave and Ivan. For example, they did recently a talk on talking KotLand. So if you just search for talking KotLand HTTP4k, you'll see them. You can also search for the talk at HTTP4k conference a couple of years ago, or you can search for the more recent talks, for example, this one, test-driven apps with HTTP4k. Obviously, HTTP4k has a website, so you can easily find it and read documentation there. It also has like blog posts with lots of interesting things. And if you have any questions, there is a Slack channel on KotLand. On KotLand Slack, there is an HTTP4k channel. And if you have any questions, you'll get them answered usually quite quickly. And this is it, really. Thank you for watching.